Okay, good morning. Okay, let's continue from where. Do you have any question? Okay, let's continue. So we were looking at the echelon forms of the matrix, and in echelon form, to transform the matrix into the echelon form, then we use the row reduction method. Use the row reduction method. So let's look at example number 2. Example 2. How can we write the matrix in row echelon form? Now, how can we get the pivot columns and the pivot positions? So example number 2. Find 2 different echelon forms for the following matrix. For the following matrix. Cycle the pivot positions and find the pivot columns in the obtained echelon form matrices. So if we have this matrix here, 1, 3, 5, 7, 3, 5, 7, 9, 5, 7, 9, 1. So how can we write this matrix in echelon form? So we had so what you need to do is we write this one into the form whereby there are all non-zero rows above the 0 rows. And then the leading entry is non-zero row. In the non-zero row is strictly to the right of the leading entry in any row above the non-zero. So what we need to do is we need to use the row reduction method. So we need to use the row reduction method. So how can we use the row reduction method? So we need to apply the finitely many elementary row operations. Finitely many elementary row operations. So I want to do this slowly because we will be applying this one in most of the examples in this course. So let's do it this one slowly and make sure you understand. If you have any question, you can ask. So the first step is we want to make this to be 0, this one to be 0, and this one to be 0 by applying the elementary row operations. Now, how can we make this second row or this to be 0 here? So what do you do? So to get the new R2, then we say R2, in this case is what? R2 minus what? 3 R1, right? R2 minus 3 R1. So here, then we retain the first row there. So R2 minus 3 R1. So this 3 minus 3 here is 0. Okay. And then this 5 minus 9 here is what? Minus 4. And then this 7 minus 15 is minus 8. And then this 9 minus 21 is what? Is what? Minus 12. Is minus 12. Then also we want to make this to be 0. We want to make this one to be 0. So the new R3 is now R3, okay? And then minus what? 5 R1. R3 minus 5 R1. So 5 minus 5 is 0. 7 minus 9 is 7 minus 9 is what? 15. 7 minus 15. Oh, sorry. 7 minus 15 is what? Negative 8, right? 9 minus 25 is what? Negative 16. And then 1 minus 35 is minus 34. Minus 34. Okay. Now, so this is the first pivot position. Okay. Then this is also the second one because there are zeros before that that leading entry. Then again, we also want to make this one to be 0. So we want to make this to be 0. So how can we make this one to be 0? So how can we make this to be 0? So here, then our new R3 will be what? So our new R3 would be, so this R3 minus 2R2 minus 2R2. So the first one is still the same. And then the second one is still the same. And then the new R3 will be 0. Minus 8 minus 8. That will give us a 0. Minus 16 minus 8. is giving us what? Minus 16 again is giving us what? 0. And then minus 34 minus 24 is what? It's giving us minus what? Now, we can see from here that this has now been reduced. So this has now been reduced to echelon form. So this is the first one. So it says find two different echelon forms. So this is the first one. So in this case, we have the pivot position. So this is one. This is the next one. And then this one is the last one. So the pivot positions here are 1, 1. The next one is 2, 2. And then the last one is 3, 3. Those are the pivot positions. So what are the pivot columns here? It is in the first, in the second, and the what? And the fourth, and the fourth. So in the first, second. So those are the pivot positions and the pivot column. Now, this is the first one. Again, we can reduce this matrix. So we have 1, 3, 5, 7, and then 0, minus 4, minus 8, minus 12, 0, 0, 0, and then minus 10. So we can reduce again this matrix. So what can we do? We can still get the new R2 by multiplying by -1/2 R2. Whereby we now have 1, 3, 5, 7, and then 0. We have not even by 1/4, by -1/4, by -1/4. So we get here 1, we get here 2, and then we get there what? 3. Then our new R3 here, R3 can be multiplied by -1/10 R3, where we have 0, 0, 0, and then 1, 0, 0. So therefore, in this case, we still have the same pivot position here, pivot position here, and pivot position here. And this is first, the second pivot column, and the third pivot column. So those are the two. So you can have this, or you can have. Any question up to that? Any question?
So on the pivot position for the bold one, wouldn't it be on 3, 4? Because it's the fourth column over.
Oh, sorry. It is 3, 4. Actually, it's not 3, 3. So it is 3, 4. It's the third row and fourth column. Any other question?
So you said that second time, were you just trying to get everything back to 1?
Yeah, we are trying, actually, we are trying to make this one 1. We will see now the reduced one, completely reduced. So to completely reduce, we are trying to completely reduce this one, 1. And then the ones which are above, the pivot positions should be zeros. This one should be 0. So that one is reduced completely, which we are coming to that right now. Okay, now example number 3. If you are asked to cycle the pivot positions and find the pivot columns for the matrix in example 2. In example 2, cycle the pivot positions and find the pivot columns in example 2. So what you only need to do here is, once you have done all this, so the only thing, so we have 1, 3, 5, 7, 3, 5, 7, 9, and then 5, 7, 9, 1. So the solution so what you only need to do here is you cycle the pivot positions and get a pivot column. So we have solved here. So what we only need to do is you cycle that. We have that, and the last one here. So those are the pivot positions here, which we got from here. So the pivot columns are just the same thing. So it is in the first, the second, and the third columns. The third columns. Anyway.
You all work it up. How is there a way to know those are?
So you need to do. You plan to do that to get out of this. The questions can be cycle and pivot positions, find the pivot columns for the matrix. So you just, after doing all this, then you just come cycle. Okay, now let's now come to the reduced echelon form matrices. The reduced echelon form matrices. So this is 1.3 reduced echelon form matrices. So what we need to do here is number one, the leading entry in every non-zero row is 1. The leading entry in every non-zero row is 1. Number 2, there is exactly 1 non-zero entry in every pivot column. There is exactly a non-zero entry in the pivot column. In the pivot column. Now, here you can say every matrix can be transformed. Into a unique reduced echelon form matrix. And this is called the reduced echelon form of the given matrix. So what are the procedures of reducing this matrix? So let's look at the procedures of reducing this. So let's look at 1.4, the procedure for finding the reduced echelon form of a matrix. So number one, first one is from the first row to the last row, you need to eliminate all non-zero entries below every pivot positions. From the first row to the last row, eliminate all non-zero entries below every pivot position. So that is the first step. The second one is you need to reduce the leading entry in every non-zero row to one by rescaling all entries in this group. Number three, from the last row to the first row, eliminate all the non-zero entries above every pivot position. From the last row to the first row, eliminate all the non-zero entries above every pivot position. So like what we can use the same example. We can use this same example here. And we can name this one as example number 5. Example number 5. So we have this, we can say find the reduced echelon form for the matrix in example number 2. Find the reduced echelon form of the matrix, example number 2. So we have this matrix 1, 3, 5, 7, 3, 5, 7, 9, 5, 7, 9, and 1. So we have already reduced this matrix to reduce echelon form to echelon form, actually, to the form 1, 3, 5, 7, 0, 1, 2, 3, and 0, 0, 0, 1. We have already reduced this to echelon form. So that one was to echelon form. Now, we want to reduce again this matrix to reduce echelon form. So we have done up to step number, actually we have done up to step number 2 here. We have made all the leading entries to be one. Now, we want to do number 3. From the last row to the first row, eliminate all the non-zero entries about every pivot position. So we have this, so we want to make this one and this one to be 0. We have this, we want to make this one like that to be 0. So how can we do this? So to reduce this to be zeros here, so in this case, we want to get the new R2 here. We want to get the new R2 there. Then to get the new R2, Then what do you do? So this is R2 minus what? Minus 3 R minus 3 R3. R2 minus 3 R3. So here we have 1. Okay. So we can also we want to reduce also this to be 0. We want to reduce also this one to be 0. So the new R1, the new R1, yeah, is the same as what? R1 minus 7 R3. R1 minus 7 R3.
That's supposed to be R2, and then R2 is R2.
Yes, this is R2. Sorry. So this is. So that is R2. So to get the new R1, then R1 minus 7. To get a new R2, then R2 minus 3. R2. So let's start from the first one, R1. So R1 is R1, which is R1 minus 3 minus 7 R3. So this is still 1, this is still 3, this is still 5, and then this is 7 minus what? Minus 7. 7 minus 7, you get the 0 there. Get 0. The new R2 will now be R2 minus 3 R3. R2. So we have 0, we have 1, we have 2, and then lastly we have 0 there. And then here we have 0, 0, 0, and 1. 0, 0, and 1. Any question after that? So we are trying to make this one R2, get a new R2, R2 minus 3. Get a new R1 is R1 minus 7. R3. Okay, so this is the leading entry. So that means we want to make this one to be what? 0. So we want to make that to be 0. So then, this case, then we will say to get a new R1, then this is the same as R1 minus 1, minus 3 R2. R1 minus 3 R2. To get a new R1, then R3. R1 is equals 3 R3. So in this case, we have 1. So 3 minus 3 is 0. Here, 5. We are here, right? So this is 5 minus what? 5 minus 6. You get what? Minus 1. And then we have 0. And then we have 0, 1, 2, 0. And then 0, 0, 0, and 1. 0, 0, and 1. So this is now our reduced. So this is now the reduced echelon. This is now the reduced echelon form. Any question up to? Use step number 3. That is on 0. Okay. Now, this one now is leading us to the next section, which is now Section number 2, which is the solutions. The solution set of a linear system. The solution set of solving actually linear systems. The solution set of solving the linear system. Now, this will give us the first section, which is 2.1, and this is the basic and free variable. The basic and free variable. So what is a basic and free variable? So we can say a variable in a linear system is called basic variable if the column corresponding to this variable in the associated augmented matrix is a pivot column. Otherwise, the variable is called a free variable. Otherwise, the variable is called a free variable. So where we have the pivot position or the pivot column, then that is what we call the basic variable. But if there is no pivot column, so if the column is not a pivot column actually, then it becomes the free variable. The free variable. The free variable. Now, what is the procedure of now solving the linear system? So 2.2, let's write the procedure or the row reduction method for solving linear system. The row reduction method for solving a linear system. So number one, so what you need to do is you need to write out the augmented matrix of the linear system. You need to write out the augmented matrix of the linear system. That is what we have done in most of the examples. Number two, you transform the augmented matrix into the echelon form matrix. That is what we have done in the example above. Number three is we need, if there exists contradictory row in echelon form matrix above, from after reducing to reduced echelon form, and then you find the contradictory. You still remember the contradictory row. Then in this case, we will not get the solution of that matrix. So if you find the contradictory row, then the linear system is inconsistent. The linear system is inconsistent. Otherwise, you will not continue from there. So if the linear system is inconsistent, then you cannot get a solution of that linear system. So if there is no contradictory row, then now you can continue from there. Then you can go to step number 4 by now transforming the echelon form matrix into the reduced echelon form matrix. And then number 5, you need to determine basic and free variables. And then finally, number 6, express every basic variable in terms of the free variables and constants, where the free variables can take on any number. So those are the steps that you need to use to solve the use of row reduction methods. So we have done all these steps. So the last one here, the last two here, is what you need to learn how to get a basic free variables and how to use both free variables to get any value there. Any value. So example number 1. Example number 6. So example number 6 in this section. Yeah, use the row reduction method to find all solutions of each linear system. So if we have this x1 minus 4x2 plus 7x3 equals to 1, 3x2 minus 5x3 equals to minus 3, and minus 2x1 plus 5x2, 8x3 equals to 1. Equals to 1. Now, how can we get the solution of this system? So the first step, write this in augmented matrix form. So the solution. So write this in augmented matrix form. So we have 1. We take the start by writing the coefficient matrix, and then now after the coefficient matrix, then what was the other? What was the name of the matrix and the matrix? So the coefficient matrix will be 1, -4. Also, make sure you check the signs here for the coefficient matrix. -4, 7. When you put now 1, becomes the augmented matrix. We have 0, 3, and -5, and -3. Then we have -2, 5, -8, and 1. Again, I say, make sure that there is a value here. It should not be what? 0. If there is a 0, then you do what? you switch that. Switch the rows. Now, we now reduce. So they have already reduced for you this. You start by reducing this one to reduce to the echelon form. They have already done it for you this. Then you go to the next one here. So how can we get the new R2? So the new R3, sorry, the new R3 will now be R3, yeah, R3 plus 2R1, R3 plus 2R1. We want to make this one to be 0. So what do you get here? So we get 1, -4, 7, and 1, 0, 3, -5, -3, and then we have 0, and then we have -3 here, yeah, right? And then we have 6, and then we have 3 there. 3. Okay, so we also want to make this one to be 0. So we want to make that to be 0. So our new R3 is now R3 plus what? Plus R2. R3 plus R2. So we have 1, -4, 7, and 1. We have 0, 3, -5, -3. Have 0. This one will be what? This plus that is 0. 6. 6 plus minus 5 is 1. And then finally 3 plus minus 3 is 0 there. 0 there. Okay, so that is now the echelon form. So we have the pivot positions. So we have the pivot position here. So that means it is this, this, and this. Step number 3. Is there a contradictory row? Is there a contradictory row? Contradictory row is where all these are zeros, and then we have a bar. It is not right. So that is not contradictory. It is not contradictory. Now, we now come to the reduced echelon form. We now come to the reduced echelon form. So we now want to reduce these ones to be zeros, these ones to be zeros. So in this case, then to reduce those ones, then we need to now make the new R2 here is the same as the new R2 there. These are the leading entries there. So those are the pivot positions. So we want to make these to be zeros above the pivot position. So we might want to make this to be 0 and this one to be 0 and this one to be 0. So to get a new R2, then it means R2 plus what? Plus 5 R3. To get a new R2 is R2 plus 5 R3. And then also to make this one to be 0, then the new R1 should now be R1 minus 7 R3. R1 minus 7 R3. So once we reduce this matrix, then what do you get? So we get this one 1 minus 4. This is 0 now, and this is 1. And then we have 0, 3, and then this is now 0. And then lastly, there will be minus 3, and then 0, 0, 1 here, and then 0 there. 1 and 0. Now, said also, for the reduced echelon form, then we need to make this one to be what? 1. So we want to make that one to be 1. So the new R2 will now be 1/3 multiplied by R2, which we now get 1 minus 4, 0, and 1, and then 0, 1, 0, and negative 1, 0, 0, 1, and 0. 0, 0, 1, 0. Now, these are the leading entries. We already made this one to be 0. We now want to make this to be 0. We want to make that to be 0. So what will be our new R1? So our new R1 will now be R1 plus 4 R2. R1 plus 4 R2. So finally, we get 1, we get 0, and then we get 0, and then we get the last one is what? We get 3. Then 0, 1, 0, negative 1, and then 0, 0, 1, and then 0, 0, 0, 1. So therefore, we now have that. So in this case, this is x1, x2, and x3. And this is the solution. So in this case, we have only the basic variables. Here we have, because this one is the leading entry, we don't have another one, because all these, the first, the second, and the third rows are giving us the pivot positions, right? They're giving us the, so these are the pivot columns. So all these columns here are giving us the pivot positions in each of them. So therefore, in this case, we don't have the basic, we have the basic variables, which are x1, x2, and x3. The basic variables are x1, x2, and x3. The free variables are none. So we don't have the free variables. We don't have the free variables. So therefore, the linear system here will now be x1 equals to -3, x2 equals to -1, and x3 equals to what? Equals to 0. X3 equals to 0. So these are the new. So therefore, these are the what? The solution of that linear system. So therefore, this one is the solution set. The solution set. The solution set. Any question after that? Any questions? So that is how you can solve that linear system. So when we meet next time, then we'll see. Now, if we have the free variables, then what happens? So if we get the free variables, if therefore we have most of the time we can get the free variables if it is an 4x4. We'll see when we have the free variables. Then what will we do to get a variable? X3. Okay, so make sure you're converting your homework into PDF. I was finding it hard to print some of your homeworks. So if you did not, I found 2 guys, they did not convert it to PDF, so I was not able to print it. So if you are able to convert it to PDF, you can still send it to my email. Okay.